Hi everyone, welcome to today's another video session for data structures, and today's topic is double-ended queue. So double-ended queue is also known as a deck. Okay, so the deck stands for double-ended queue. So as its name says, like a queue is having both insertion and deletion. That is like NQ and DQ operations can be performed at both ends, can be called as a double-ended queue. So Dequeue is a linear data structure where the insertion and deletion operations can be performed from both the ends. So we can say that Dequeue is a generalized version of the queue. Okay. So though the insertion and deletions in a deck can be performed on both ends, it does not follow the first in first out rule. Okay. So the representation of a DQ can be seen as that you can show see in this figure. Okay, so that blue is the one like a queue, like a deck. Okay, you can see that insertion can be done at beginning and as well as at the end. Similarly, the removal, that is DQ, can be performed in the beginning of the queue, that is at front or at a rear. Okay, in a normal queue, you can say that at the front we can perform only DQ, that is removing the elements. The insertion can be done at end, that is at the rear. But in deck, insertion and removal can be done at both the ends. So there are different versions of this DQ available. Okay, so we see the types of DQs. Okay, there are two types of DQs. Okay, you call it as a input restricted queue and output restricted queue. Okay, so input restricted queue means like you can perform insertion at only one end, but deletion can be done at both the ends. Similarly, output restricted queues is like you can insert at both the ends, but output or deletion can be done at only one end. Okay, so you can see that input restricted queue and input restricted queue insertion operation can be performed at only one end, while deletion can be performed from both ends. Okay, so we can see here in this figure, like in the beginning we can perform the insertion and as well as deletion at the front, but at the end of the queue at the rear only we can perform deletion. So we are restricting insertion at the end, so you call it as a input restricted double-ended queue. Okay, similarly we are having output restricted queue. So in output restricted queue, deletion operation can be performed at only one end, while insertion can be performed from both the ends. In this figure you can see that in the front, that is, you can perform only insertion, but at the rear you can perform insertion and as well as a deletion. So what is the option that we have actually removed from here is like we just remove deletion operation in the beginning, so we can say output restricted double-ended queue. Okay, so what are the different operations that can be performed on DQ? So there are the following operations that we can perform on a DQ: insertion at the front, insertion at the rear, deletion at the front, deletion at the rear. Okay, so by just looking at the titles, you can easily understand what is the concept and all. Okay, so we can also perform various operations like the peak operation. So that means, okay, what is it? The element at the rear in the deck. Okay, but though the peak operation, we can get the DQ front and rear elements of the. So in addition to the above operations, the following operations can be also supported in the DQ. So we can see that like get the front element from the DQ and as well as we get the rear element from the DQ. Similarly, you can check whether the DQ deck is full or not. Similarly, you can say the deck is empty or not. Okay, so now let's understand the operation performed on the deck, that is double-ended queue, using an example. Okay, so insertion at the front. So in this operation, the element is inserted from the front of the queue. Before implementing this operation, we first have to check whether the queue is full or not. Okay, so whenever you try to insert an element into the queue, we need to check whether the queue is full or not. If the queue is full, we cannot insert elements into the queue. Okay, so if there is a place, then only we can insert element into the queue. So what are the things that we should check before we insert the thing is like if the queue is empty, both rear and front are initialized with 0. Now both will point to the first element. Okay, or in other way, like we can say that if the queue is empty, the both insert and front and rear can be pointed to the -1. Otherwise, check the position of the front. If the front is less than 1, okay, then the reinitialize it with the front equals n-1. That is the last index of the array, right? So these are the different operations like we can perform. Like in the figure, you can see that at the front there is an element 7, at the rear there is an element 1. Okay, so you can say that front is at 0, okay, rear is at index 2. Similarly, so to reinitialize it, so front can be moved to n minus 1 as a last index. Okay, so rear is at index 2 and front is at index 4. Okay, now add the new key to it. Okay, so there is a, you can insert an element 5 to the front. Okay, insertion at the rear. Okay, in this operation the element is inserted from the rear end of the queue. Before the implementation operation, you first have to check again whether the queue is full or not. Okay, so if the queue is not full, then the element can be inserted from the rear end by using below conditions. Okay, so if the queue is empty, both rear and front are initialized with 0, or you can initialize them to -1. Both will point to the first element. Okay, so otherwise increment the rear by 1. If the rear is a last index, then instead of increasing it by 1, we have to make it equal to 0. Okay, this is like front and rear. Okay, so to insert a new element into the deck, okay, so we need to increment the rear pointer to the index 3. Okay, then you can place your new element 5 into this index 3. Okay, similarly you can perform deletion at the front. In this operation the element is deleted from the front end of the queue. Before implementing the operation, we have to check whether the queue is empty or not. If the queue is empty, that is front equals to -1, it is the underflow condition and we cannot perform deletion. If the queue is not full, then the element can be inserted from the front end by using below conditions. If the deck has only one element, then set rear and -1, so rear to -1 and front to -1. Then you can delete the element. Else, if front is at the end, okay, that is the size -1. Set front to 0. So else increment front by 1. Okay, so these are the things you need to look in when you are deleting elements. Okay, so in this example, you can see that front is at index 0, rear is at index 2. Okay, in the front there is a 7 and at where there is a element 1. Okay, if I am using delete front, so that 7 will be deleted and front should be incremented to the index 1, right? Similarly, deletion at the rear. Okay, if this operation, the element is deleted from the rear end of the queue before the implementing the operation, we first have to check whether the queue is empty or not. If queue is empty, that is front at -1, it is underflow condition and we cannot perform deletion. If the queue has only one element, set rear and front to the -1, because after removing element, the front and rear comes to the -1. Similarly, if rear is a 0, okay, that is rear is at the front, then set rear to n-1. Okay, so after deleting an element, so it has to go back to the n-1. Okay, because it can't go to index 1. Okay, so you need to take it back to the end of the queue, so else decrement the rear by 1. Okay, so you can see here in this particular example, the deck is having 7 at front and 1 at a rear. Okay, so front is at index 0, rear is at 1, and we are deleting from the end. So 1 is deleted from the index 2 and rear should be decremented by 1, so it comes to the index 1. So check empty, like how do you check whether the deck is empty or not? So this operation performed to check whether the Dequeue is empty or not. If a front equals to 1 or rear equals to empty equals to -1 or rear equals to -1, it means that the deck is empty. Similarly, for checking whether the deck is full or not, okay, so this operation is performed to check whether the deck is full or not. If front equals to rear plus 1 or front equals to 0 and rear equals to n minus 1, it means that the deck is full. So the time complexity of all the operations of the deck is order of 1, that is constant time. So what are the various applications of the deck? Or deck can be used as both a stack and as well as a queue, as it supports both operations. So deck can be used as a palindrome checker, means that if you are read a string from both the ends, the string should be the same. So this is the program for implementing a double-ended queue. So I have implemented this code in Python. Okay, so this is all the code. Okay, and I created a menu kind of a program, so you can see all these things. Okay, I'll show you the execution part. Okay, so guys, I have copied the program, so I'm just I've taken an online compiler, GDB compiler. Okay, so this is the program wherein we have created the deck as a menu kind of a program. I'll execute and try to see how the output looks like. So you can see that this is the output. So it is displaying a queue operations as a menu. Okay, so I'll give the choice as 1. So I'll enter the data 10. So We try to see option 5, that is displaying. You can see the double-ended queue contains the value 10 because just now we entered the first element. Okay, so I'll take the option 2, that is add the element at the end. So I'll enter 20. So you can see that 20 is added at the end. So after 10, I'll take the first option again, that is 1, and I try to give value 30, and I'll check whether 30 is added at the beginning, that is upfront, that is before 10 or not. So you can see that 30 is added before 10. So 30, 10, 20 are currently there, right? So I'll take another option called 3. So delete front option, I have taken option number 3. So the element at the front is actually 30. So that is actually deleted. Okay. And again, the remaining deck is 10 and 20. I'll take the next option called option number 4. That is at delete at end. So end there is a 20. So we see like the element deleted is 20. We try to see like what are the elements in the deck. So that is a 10. Okay. So again, we try to delete 10 also. So element deleted is 10. We try to see what are the elements in the deck because there are no elements. So it says like list is empty. Okay. So this is the double-ended queue execution, my friends. So hope you understood the concept of double-ended queue. So double-ended queue is simply like we can perform insertion and deletion both at the front and as well as at the rear. So that is called the double-ended queue. So hope this video is useful for you. Thank you for watching for my video. Bye.